Hello friends, today we are going to discuss the transport in plant lecture 06. In last video lecture I have discussed it, but for English medium student I am going to discuss it separately. Initially ignore this diagram because we will use it later. So in our last lecture we have discussed the imbibition. So what is the imbibition process? Let's take a review. In imbibition, we discussed that it is the adsorption of any liquid around the particles of a colloidal solid by adsorption, as we have said earlier, and without forming any solution. So adsorption of any liquid around the solid particle without forming any solution is called imbibition. So we have discussed that what happened in this imbibition. There occur two substances, imbibant and imbibate. This imbibate is some liquid material. In our cases it is water. Imbibant is some solid material like protein, like carbohydrates. Starch itself is a carbohydrate, agar. These material can imbibe the water by adsorption of it around their particle. So in this process, these particles bind the water, water loses its kinetic energy, which appears in the form of heat of wetting, and due to water becomes the part of the solid, the overall volume of the material increases, which causes development of huge amount of pressure, which we call imbibition pressure. But later we used the term metrical potential for this imbibition pressure. So we have discussed the imbibition, we have discussed imbibition pressure, we have discussed heat of wetting. One important thing, that for imbibition to occur in this imbibant, more negative or highly negative water potential should be present, so that water can enter into it, and capillary force also works there. These all things I have told you in the last lecture. So this was brief discussion of imbibition. The example of imbibition was that swelling of wooden furniture in rainy season, breaking of seed caught during seed germination, and during water absorption. Root here first show the imbibition pressure. We will discuss this process when we will discuss the root of water absorption. This diagram is related to that process, but we will discuss it later. So now, after this imbibition, we have covered all the topics related to short distance transport. Short distance transport includes diffusion, active transport, osmosis of water, facilitated diffusion, and we already discussed different type of pressures and potential related to that, and the relation or interrelation between those pressures and potential and the movement of water according to those pressure and potential in our last lectures. So now we are going to discuss the very important kind of transport in plant, that is long distance transport. What do we mean by long distance transport? Let's see. Long distance transport. Long distance transport actually includes transport of material from one part of the plant to another, like from root to aerial part, from aerial part to roots and other plant parts. So what kind of material is going to be transferred from one plant organ to another? There are several material. We can see that water is absorbed by root from soil, and it has to be transferred to aerial parts through the stem, then leaves, and then into environment by transpiration. So such kind of transport are included under the heading of long distance transport. So long distance transport includes transport of water from root to the aerial parts, transport of organic food from aerial part to the roots and other plant parts, and absorption of water from soil to the plant and release of water from plant to the environment. These all type of transport are included in long distance transport. So we have seen certain factors which help the material for their short distance transport, like diffusion, active transport, etc. But for long distance transport, such factors are not capable enough. Why? We can see. Look, if we consider diffusion, then we will find that to cover the 15 micrometer distance, diffusion takes almost 2.5 seconds. This time is enough for this distance, and this distance is enough for cell to cell movement or movement within a cell or from cell to exterior. But if we consider the long distance, like if a plant is, if the height of a plant is 1 meter, then from this speed, diffusion will travel this distance in few years. So, is there any significance of this process in long distance transport? Not at all. So, we can say that the factors helping in short distance transport are quite useless for long distance transport. So, which factor help in such long distance transport, and how long this distance can be? This distance can be long enough up to 100 meter in few plants. So, for this distance, such factors are not going to be helpful. So, with which process we can understand the long distance transport? So, we consider few kind of pressure gradients to make this long distance transport possible. What are these pressure gradients? Pressure gradients means huge difference of pressure between 2 points. When certain parameter changes according to distance, then we call it its gradient. So, suppose it is root and it is leaf. So, if from root to leaf the huge difference of pressure is present, then it is pressure gradient. Suppose pressure is high in leaf and low in root, and certain material is shifted towards root to leaf, then it is kind of pulling by leaf. So it includes as it is considered as a negative pressure gradient. When there is kind of pulling force, it comes under negative pressure gradient. And suppose in certain movement pressure is greater in leaf and lesser in roots, and the material is shifted towards leaf to root. So it is kind of push from leaf to root. So such kind of forces are considered as positive pressure gradient. So pressure gradients can be of two types, positive and negative. Positive pressure gradient are like some kind of push, while negative pressure gradient are like some kind of pull. As we suck the juice from a straw, it comes under negative pressure gradient. And as the pumping motor pushes the water up to very much height, this comes under the positive pressure gradient. So, any kind of pressure gradient can help in long distance transport. It can be positive or negative. But for long distance transport, there should definitely be present huge pressure gradient. Okay. So this is the process which helps in long distance transport. Because of this, we can say this long distance transport as mass flow and bulk flow. You can say this mass flow and bulk flow. Long distance transport are also called as mass flow or bulk flow because in this type of transport all material carried together in dissolved state with water. Like we can see the flow of a river. In the river flow, every material dissolved in water flow at same pace. That's happen in long distance transport inside the plant body. That every material flow in dissolved condition with water and every material flow at same pace like a river flow. That's why it is called mass flow or bulk flow. Okay, so long distance transport can also be known as mass flow and bulk flow, and this mass flow and bulk flow can be made possible by pressure gradients which can be positive or negative as well. Okay, so this is the introduction of long distance transport. Now we will discuss different types of long distance transport in plant body. In this, at first comes the water absorption through root. So our first topic of discussion will be water absorption here. So what does this water absorption means? It means absorption of water from soil with the help of roots. We know very well that source of water for all plant is the soil. The chief source of water is the soil, and it is absorbed with the help of roots. So entry of water from soil solution to the root is called water absorption. So first we need to consider the soil solution and the type of soil water. So first we will discuss about the soil water. We know that in soil water is present in a solution, but the major source of soil water is the rainwater. From where this water comes? From rain. Chief source of soil water is rain. Sometimes irrigation also help to maintain or build up the soil water, but the chief source, ultimate source is the rainwater. Okay? When rainwater comes, it becomes the part of this soil. But soil water can be categorized in different types, like it can be gravitational water, it can be capillary water, it can be hydroscopic water, it can be chemically combined water. So these type of soil water can be present inside the soil solution. So what does they mean? First we take the gravitational water. What is the gravitational water? As we know that after rainwater comes in the soil, it will percolate towards the ground. We know that soil particle has enough space in between them. So when water collects over the soil surface, it will start to go down through these pores or through these spaces. If soil particles are smaller and the space between them is bigger, this water can easily percolate and can easily goes down and becomes the part of water column present beneath the soil. जमीन के नीचे जो पानी होता है ये उसका हिस्सा बन जाएंगे क्योंकि सॉइल पार्टिकल के बीच में से एक तरह से लीक होकर रिस्क कर परकोलेशन प्रोसेस से ये नीचे चले जाएंगे. Now we can see this gravitational water is present at much depth, and up to this depth roots of most of the plant cannot reach. So this water is not available to most of the plant. there are few exceptions in which roots can reach up to the gravitational water. The important example is prosopis. It is the state tree of state Rajasthan. खेजड़ी इसको कॉमन लैंग्वेज में बोला जाता है और इसकी जड़ें इतनी गहराई तक चली जाती हैं कि ये जमीन के नीचे जो पानी मौजूद होता है ये उसको भी रिसीव कर सकते हैं. So such plants are technically known as phreatophytes. We will discuss this term in ecology, but these are very exceptional plants. Normally this gravitational water is not available for most of the plants. So this is of no use for plant. Then capillary water. What is the capillary water? If the size of soil particle is larger, then the water is held between them by capillary force, because capillaries are formed between the soil particle, because the space is very less and soil particle size is greater. So in these capillary water heads, and due to the presence of capillary force, this water opposes the gravitational pull towards the ground and it can remain in between the soil particles. So this water is left in between the soil particle and roots or root hair easily reach in between these spaces. That's why this water becomes available for most of the plant. This is the most important type of water which becomes available for majority of the plants. So capillary water is the water of use for most of the plant. Okay. Again, next is hygroscopic water. Hygroscopic water is actually the water which is bound around the soil particle by the process of imbibition. This is moisture which is bind around the soil particle. So this water is tightly held over the soil particle surfaces, so plant roots cannot receive it. So the hygroscopic water is not available for most of the plants. Only few orchids can absorb this water from the moisture present in air, not through the soil. So only roots of orchids can absorb the moisture, but from the air, not from the soil. Okay. So hygroscopic water is mostly not available for most of the plants. Okay. So this is what this again is of no use. Then comes the chemically combined water. What does this mean? The chemically combined water. Chemically combined water is the water which combines with soil particle chemically. Means there are few chemicals present in the soil, like you have heard about copper sulfate, iron sulfate. These are the chemicals which can be hydrated with water. Few crystalline water is present with them just because of their hydration. So the hydration energy is quite enough so that this chemically combined water cannot be separated from these chemicals. So this water is combined with the chemical by the process of hydration, so it is not received or it cannot be received by the roots of the plant. So this water again is not available for plant. So from all type of soil water, the only water which can be available for plant is the capillary water. So capillary water is the water of use. All other types of soil water are of no use for the plants. Okay. An important chemical term is also used for soil water. The total soil water is called holard, and this holard is of two types. One is ecard and other is cresard. So the total soil water is called holard, and holard is of two types, ecard and cresard. The ecard is the water of no use. इस water को plant इस्तेमाल नहीं कर सकते. So this is useless type. But the cresard is the water of use or useful type of soil water. So this water can be received by plants. So crisard is the type of soil water which can be received by plant, and ecard is the type of soil water which cannot be received by plants, and both collectively are called bollard, which suggests the amount of total soil water. So this is all about soil water. Now we will discuss how this soil water is absorbed by roots. Okay. So first we will discuss the mechanism of water absorption. First we come to the mechanism of water absorption. So by different theories, this mechanism is explained in which two important type of mechanisms are included. First is active water absorption and second is passive water absorption. The mechanism of water absorptions are of two types, active and passive. Initially, we will discuss the active water absorption. What does this mean? Active water absorption. Okay, so listen carefully. The active water absorption includes all those processes in which root cells actively takes part in water absorption and water enter into the root cell. If it is a root cell, then water definitely enter into the root cell cytoplasm. So what do we mean by active absorption? The absorption process in which root cells actively takes part in water absorption and water definitely enter inside the root cell and becomes the part of cytoplasm of root cell. Then only we will call it active water absorption. So how does this happen? Active water absorption. Listen, there are two types of active water absorption. Two types are included under the heading of active water absorption. First is osmotically active. First we will consider the osmotically active water absorption. How does this happen? Look, if this is root and these are little branches of roots and these are very tiny root hairs present in the root. So like this is epidermis of root and this is root hair and these are soil particles and this is water present around them. Okay, so when this root hair or the cell of root hair come in the contact of soil water, what happens? Mostly the solute concentration of soil solution is higher. Solute concentration of soil solution is lower and its osmotic pressure is lower than the root cells. Root cell solute concentration is higher, its osmotic pressure is higher, because in the root cell more amount of solutes and less amount of water is present, while inside the soil less amount of solute and more amount of water is present. So this maintains the osmotic concentration gradient. That's why water enter from soil to root, but through the membranes of root cell, which act as semi-permeable membrane. And when water goes from its higher concentration to the lower concentration through semi-permeable membrane, the process is called osmosis. So in this case, water enter into the root cell by the process of osmosis, and this process is called active because water enters directly into the cytoplasm of root cell. So this process is osmotically active. Osmotic process always occurs along the concentration gradient. Water always moves from its higher concentration to lower concentration. Water always moves from less solute to more solute, from less OP to more OP. So this is the movement along the concentration gradient, so there is no need of expenditure of any kind of energy. Though we use term active in this water absorption, but here is no expenditure of metabolic energy. So in osmotically active absorption, there is no expenditure of metabolic energy. Water moves along the concentration gradient. In most of the active absorption, this process is followed because root cell maintain high osmotic pressure in the comparison of soil solution. That's why water follows the osmotic concentration gradient and enter inside the root cell. And when water enter in the root cell cytoplasm, we can consider it active because root cell is actively taking part in this absorption without expending any kind of energy. Okay, so first type of active absorption is osmotically active. Then we consider the second type, which is non-osmotically active water absorption. As the name suggests, here osmosis is absent. Why osmosis is absent? Because concentration gradient does not favor the process of osmosis. Why? Because the soil solution and root cells has inverse concentration gradient. Now the concentration gradient or the solute concentration is higher in soil while lesser in roots. So through the semi-permeable membrane, the movement of water by osmosis cannot occur in this direction from soil to root. If osmosis occurs, then it will happen from root to soil. But it is not desirable. Root cannot lose their water. Root always need water from soil, though their present water is in higher concentration or in lesser concentration. But root always need water. So how root will absorb water this time? This time they need to spend the metabolic energy. They need to spend the ATPs. So on the expenditure of metabolic energy, this water is obtained from soil to root. It is against concentration gradient. That's why expenditure of metabolic energy will take place. So this process is active because the roots actively takes part in this absorption by the consuming the metabolic energy, but osmosis does not happen and osmotic concentration gradient is not followed. The movement of water occur against concentration gradient on the expenditure of metabolic energy. That's why this process is called non-osmotically active. Though it is active because root cells participate in this process actively, water enter inside the cytoplasm of root cell, but osmosis does not happen. Okay? So active absorption are of two types: osmotically active, non-osmotically active. In osmotically active, movement of water occur along the concentration gradient through the osmosis, no expenditure of metabolic energy. In non-osmotically active water absorption, movement of water occurs against concentration gradient, no osmosis will take place and expenditure of metabolic energy definitely occur. Okay, so this is all about active water absorption. But here comes one more type of water absorption, that is known as passive water absorption, and we will be amazed to know that the passive water absorption is much more important than active water absorption. So first we will discuss what is this passive water absorption. Okay, so passive absorption. Passive absorption, as the name suggests, that the type of absorption in which root cells do not take part actively and in which water never enter into the root cell cytoplasm. Then from where it will move, we can see this through this diagram. In passive water absorption, water move in between the root cells through their cell wall but never enter into their cytoplasm. This is called apoplastic route. We will discuss it later but in this process root cell does not participate in absorption of water actively. Water enter into the root through the cell walls of root cell and intercellular spaces. So water will enter into the root, but it will not enter into the root cells. That's why this process is called passive. So the question arises, where does that force come which is responsible for this type of absorption? Because water is not at all entering inside the root cell cytoplasm. So which factor is responsible for pulling this water into the root? Because in active absorption we can see either it is osmosis or it is expenditure of energy which can make it possible. But now this passive water absorption is made possible by which force? So the answer comes from some part other than root. The very important thing, the force responsible for passive absorption is not produced inside the root. It is developed somewhere other than root. Where? We will see. Look, this is, suppose, a representation of a plant body in which these are the aerial part of the plants, its branches. It is the leaf canopy, it is a stem, and then comes the roots, which are underground. So we know very well that every plant loses water vapor through their aerial parts. Every plant continuously loses water vapor into the environment through their aerial part. So when leaves continuously losing the water into the environment, then the huge demand of water is created inside the leaf cells. And leaf cells fulfill this demand from their vascular supply through their veins, then from their branches, and then this huge demand is applied over the stem of xylem. So this is stem of this xylem over the xylem of stem. So this xylem of stem always present under a kind of negative pressure gradient, means a kind of pulling force. This aerial part of the plant continuously losing water and continuously demanding water from this xylem of stem. So the water present is in this xylem continuously ascending up by this pulling force, and this pulling force is shifted to the roots from the xylem of stem. This xylem of stem is ultimately connected to the xylem of root, and the root xylem is always remain under a kind of pulling force, and this pull is the transpirational pull. And due to that pull, the xylem of root demands water from soil, and water enter into the root from soil, and it moves in between the cells through their cell wall, but never enter into the cytoplasm of cell. So this type of water absorption is considered as passive absorption, and you will definitely be amazed to know that 96%, almost 96% of water absorbed by root is absorbed by passive absorption. So this is the most important way of absorption of water through roots. And the evidence for this process is given by Kramer. Kramer noticed that during daytime, when rate of transpiration are very high, rate of water absorption are also very high. So water absorption always remains proportional to the rate of transpiration. So when transpiration is higher, rate of water absorption is higher, then definitely it suggests there is some role of transpirational pull in the absorption of water. This is known as passive absorption. But always keep in mind that in passive absorption, the root of water is apoplast. We will discuss it, we will understand this term later in detail, but now I am going to tell you that the apoplast means the cell wall and intercellular spaces of root cell, which never include the protoplasm of cell, the cytoplasm of cell. Okay, so when water moves through apoplast, it never enter into the cytoplasm of cell. Okay, so passive water absorption occurs through apoplast. So we have discussed two types of theories of water absorption: the active water absorption and the passive water absorption. And the more important type of absorption is passive water absorption, and it always occurs through apoplast. Okay, so these are the important conclusions from water absorption. Now we will discuss the route of water absorption with the help of this diagram, which we are ignoring from starting. Now we will discuss it in detail. Route of water absorption. Now the time is come where we can see the diagram and we can understand this diagram. Okay, so this is actually the transverse section of a root in which the parts or different types of tissues are elaborated from epidermis to the xylem. The outermost layer of root is the single cell layer epidermis, also known as epiblema, also known as rhizodermis. On this epidermis, unicellular root hairs are present, and we know very well that they are the root hairs which comes in contact of water at first. So when the root hair come in contact with the soil water, firstly water bind over the surface of root hair by the process of imbibition, which we have discussed earlier. Imbibition. Okay, so imbibition is also useful, and it is the first phenomena during water absorption when water bind over the surface of root hair. Okay, so we can see the unicellular root hair, the unicellular cell layer, the epiblema, the multicellular cortex, cortical cells are parenchymatous, enough intercellular spaces are present between them. Then comes the endodermis. The cells of endodermis are the barrel shaped, and their radial and tangential walls are deposited with some impermeable substance named suberin, and due to this deposition of suberin, this complete layer of endodermis is known as Casparian strip, after the name of its discoverer, Caspar et al. So Casparian strip is deposited with suberin, and this suberin make this layer impermeable for the movement of water. Below the epidermis, the parenchymatous pericycle is present, inside which the stellar region comes, in which initially protoxylem and then metaxylem we can see. Okay, so how does water enter into the root? Initially, we have seen the water particle binds over the surface of root hair by the process of imbibition. So when these particles bind over the surface, due to the colloidal nature of cell wall, as it is made up of cellulose and pectin, and this substance can bind water easily. So when water is bind over the surface of root hair, it can enter into the cytoplasm of root cell, and it can directly transfer into the cell wall of epidermis, and then further cell wall of cortical cell, and then intercellular spaces, and then cell wall. So there can be two routes for water to enter. First, in which water enter inside the cytoplasm of root hair, then into the cytoplasm of epidermis, then into the cytoplasm of cortical cell, and this movement occurs through plasmodesmata. I will discuss it later. But the important route is apoplastic pathway, and the apoplastic pathway includes the cell walls and intercellular spaces, because there is no hindrance of any kind of cytoplasm. So this apoplastic pathway is more easy for water to cover or to move. So you can see the water enter into the root mostly from apoplastic pathway. It moves in between the intercellular spaces of cortical cell as well as their cell wall, and then it reaches up to the endodermis. So in complete cortical region, the water mostly favor which pathway? That is apoplast. And apoplast includes cell wall and intercellular spaces, but never the membrane and cytoplasm. Okay, so till endodermis, movement of water mostly occur through apoplast. But when endodermis comes, we know very well that the walls of endodermis are studded with, deposited with permeable and impermeable substance known as suberin, and this suberin do not allow any kind of entry of water. So this layer acts as a check dam. This layer acts as a barrier. And how does this barrier is crossed? Look, there are few cells which are not deposited with suberin, and in these cells water can enter only through the cytoplasm, which is also known as symplastic pathway. When water moves from cytoplasm of one cell to another, the movement or the pathway is known as symplastic pathway. So in endodermis, water enter into the passage cell cytoplasm through the plasmodesmata. So here water essentially cross the cytoplasm, and water has essentially, you can say, acquired the symplastic pathway. So apoplastic pathway is followed in complete cortex, but in endodermis only symplastic pathway can help the water to move across. So always keep in mind, in endodermis water assumes which pathway? It is symplastic. So water essentially enter into the cytoplasm of passage cell and then it cross the membrane again. So in endodermis the symplastic pathway is the only pathway which is available for water to move. Okay, then when it enter into the pericycle, it can again assume the apoplast, and xylem is completely dead, so only apoplast will be there. So majority of absorption of water, or you can say path of absorption of water, is apoplastic, but in the region of endodermis it becomes essentially symplastic. It doesn't mean that symplastic pathway cannot be assumed anywhere else. It is also assumed in cortical region, but the chances are very less because the cytoplasm causes a hindrance for the movement of water. So it is quite easier for water to move through the intracellular spaces and through the cell wall. So most important pathway for water during water absorption in root is apoplastic, and this kind of movement is supported by transpirational pull. Remember what I told you earlier, that from aerial part of the plants, continuous loss of water. This loss of water causes a pull on xylem of stem. This xylem of stem is connected with the xylem of root. So this xylem of root continuously remain under the tension, under kind of a pull, and this pull causes the entry of water from soil to the xylem of root. So this is the route of water absorption. Inside root are double OT, means in root tissue. Water enter in this way from soil solution to the xylem of root. Few other things are also there which comes under consideration during absorption of water, but this is the main concept which I have told you, and majority of question can be solved by this concept. Okay, so watch this video lecture and study it, and if there is some difficulty you can ask me. In next video lecture I will explain the ascent of cell and few remaining point of absorption of water in roots. Okay, thank you.